Today I'm hanging out with my buddy Tim De Stasio from Comfort Science Solutions. He's one of the sharpest guys I know when it comes to HVAC design, commissioning, and troubleshooting the chaos we all deal with in the field. Tim and I first connected a couple years ago over ASHRAE 221, and what started as one conversation turned into him helping us rethink how we design and document our systems. But today we're getting into the good stuff, like real-world inverter hell that so many contractors are running into, like why commissioning matters more than ever before, and how to actually design and monitor these systems so they work the way homeowners think they should. Tim's been a tech, a contractor, a designer, and a trainer, so he's got decades of perspective on what works, what doesn't, and how to stay profitable while doing things the right way. Let's get into it. Hey everybody, I'm here with my good friend Tim De Stasio of Comfort Science Solutions. Hey Tim, how you doing today?
Hey Jeremy, good to be here.
Good to see you. So Tim and I'll just give you guys a little bit of history of how Tim and I met. And it's actually a pretty cool story and where we're at today. And we're going to dive into some inverter hell and talk about the world of inverters and how it can be a tricky place to play and some of the things you need to watch out to. And who knows where the conversation goes. But yep. Tim reached out to me, I think 2022, was it, Tim?
Yeah.
And we were just really hitting hard and heavy in the HVAC Design Partners brand. We had been doing a lot of marketing and stuff like that. And I forget the exact reason. ASHRAE 221. Tim reached out to me. We had been talking a lot about that. And he goes, I love what you guys are doing on the commissioning side of things. Will you chat with me? And so I said, yeah. I had never met him, didn't know him. He jumped on. We had a good conversation. And then a couple weeks later, he called me back and said, hey, I'm wanting to sharpen my pencil and do some design work. If you guys got anything you could throw my way, here's a sample of my work. And we just happened to be super busy. We were in a Lead for Homes program in Cincinnati, Ohio. We were getting crushed with design work, and I was doing all of the HVAC design review for the green building program that was the implementers of the Lead side of things there in Cincinnati, them and one other company, but we were working for Green Building Consulting at the time. And so we just had a bunch of work, and Tim started doing some subcontracted designs for us, and next thing you know, he was saying, hey, what if we did this on the deliverable, or what if we made it this way? And so he really started changing the way that I looked at my deliverable, and I started to look at Tim almost as a mentor in some things, because he's been on the installation side of HVAC a lot longer than I have. So once he got used to the crazy, and I'll let him talk about this part of it, but once he got used to the crazy Cincinnati houses and the way HVAC does business in Cincinnati, he started making some really useful suggestions to the actual constructability of our duct systems and making it more of a one-stop shop for the contractors, where they didn't have to come back and say, hey man, this thing's in the way, let's change this, or this isn't realistic out in the field, let's change that. So Tim, I'll let you talk about your side of that experience a little bit, but I actually got a lot of value out of our back and forth that we had during that time.
Yeah, it was really it was good seeing you kind of grow on LinkedIn. I was paying attention to a lot of your posts. You still are, but you were very active on LinkedIn, and I agreed with a lot of the stuff you were saying. I was like, man, I just want to talk to this guy. At the time, I'd sold my HVAC contracting business. I was working through 1 year with the current owner, and I was transitioning out of that. And I really kind of had a clean slate of what I could do at the end of 2022. And I think my contract with them ended in February of 23. So starting in February 23, I wanted to kind of hit the ground running and being able to do some of the work that I've always wanted to do as an HVAC practitioner. And you guys were doing HVAC design. It seemed like that was a good model. And it was really great to work with people that had the same passion, but also the same understanding that things don't always work like that people in a lot of these green programs say they're going to work. So that pragmatic, okay, here's what we're supposed to do. Here's what we need to do for compliance. But here's how we kind of know it's going to work. So can we just sort of maybe design around that as well? And just some of that real world experience that you have had in the trenches and I've had as a contractor who did his own commissioning, and just seeing some of the follies and some of just the ridiculousness that's in some of these programs that are well intentioned, but just don't factor in for the human error and the I don't care attitude that's in the industry, unfortunately. So we had a great time. It's cool to see your business and your consulting side taking off, and my business is taking off. And it sucks we don't get to work as often on a day-to-day basis as we used to. Maybe we can, come back to that. But your business is taking off and mine's taking off, and I'm happy that I was able to help you a little bit. And you certainly have helped me, I think, way more than I've helped you. So I appreciate that. And obviously, I appreciate this opportunity to come hang out with you today.
I appreciate that. And I think as far as the green building stuff goes, I think that you got to see firsthand that just because a building's certified doesn't mean it's a great building. There's a lot of crazy stuff that go on inside those programs because there's so much wiggle room that guys, sometimes it ends up making the house a worse house than it might be if it was just left alone and not in one of those. We've seen that, think about the amount of times that we've seen stupid stuff happen because these guys insist on doing the least inside the program instead of the most, and it gets that way. So, one Tim and I had been thinking about, like, what can we talk about that would be meaningful? And, and it's so funny because we were talking about the inverters. We had a couple really good inverter heat pump conversations just about the nuances of the different brands. And we were like, wow, this is a good topic. And then in the meantime, Brian Orr, we had been having those conversations, and Brian Orr put a whole piece out on his HVAC school podcast about inverters and like beware and the nuances. And Tim, and I sent a link to Tim in text message. I was like, look, we must be on the same wavelength here because it's becoming a bigger and bigger topic. What has been your experience so far with the different inverters, Tim? Like, what do you see we won't get brand specific, but from brand to brand, what are some of the differences? What are some of the challenges that you see with these things?
I'm going to first talk about maybe some of the challenges that I had as a contractor prior to becoming more of a consultant and designer. Just because it's the pain points that I keep hearing from contractors even today that are resistant on installing the high-end inverter modulating equipment. And one of the things is that the equipment is super expensive. And it is their premium equipment. But then if the parts tend to be very delicate. They don't handle power surges very well. They don't handle brownouts very well. And I have personally seen this where circuit boards, other parts have failed on those units, and then those parts are not readily stocked by your supplier. So as a contractor, you've sold them this premium top of the line system. For whatever reason happens, maybe it was a brownout, maybe it was a power surge a couple years later, and they have a motor or a board that goes bad. And so now the customer's like, man, I just paid thousands, $10,000, $20,000 for a new system, and now I don't have air conditioning or heat. And so you go out there and you diagnose it. They're already irate. You say, well, I'm sorry, your board has failed. Well, maybe the board is under warranty. If it is, okay, the part should be covered. The labor is not though. So now, that board that was susceptible to failure has failed. And now you're telling them that it's going to be 2 to 3 to 6 weeks lead time before you can get it fixed. That was a conundrum that I faced with a system. I'd put in fortunately, it was a dual fuel system, and it was the furnace side that had a fail part. And fortunately, that house was very efficient, and it happened during a cold spell. In North Carolina, a cold spell to us is where it gets and stays below freezing for like more than 12 hours. But we had a cold spell. It was in the single digits at night. It got up to the low 30s. Fortunately, that heat pump was able to keep up because the furnace was dead in the water. inverter. And this happened right around COVID, and it was 8 weeks before that replacement part came in, and I was just sweating bullets because I had a customer that may not have had heat if it wasn't for that heat pump. If that heat pump tried to go into defrost and the furnace kicked on, then that furnace would have faulted out and it would have had to have been reset. So I was just sweating bullets the whole time, and I just see this where these inverter units in years past, everybody's rushing to get their brand new product to the market, and they kind of skip out on the research and development and the battle testing of those systems. And then the contractor gets stuck being their research and development. The contractor ends up having systems that don't work, and then they get sent bulletins. Oh, well, for this particular model unit, we have this problem. Here's the workaround. We're going to send you this replacement part and we'll throw you $60 to put it on. Well, thank you. Now I've got to, take time away from a more profitable job to be your research and development for $60 to put this part on because you guys rushed it to market. I think these units have now been out for long enough where some of those problems have weeded out. 5 years later, now we're in a time when inverter units are a little bit more common than they were 10 years ago. So a lot of those problems aren't as prominent, but there are still tons of cases of those high-end inverter units that are failing, and the parts aren't readily available. And if the parts are out of warranty, they're very, very expensive. And people start thinking, well, this unit was supposed to save me all this energy, and one part fails, and there went all my energy savings.
How much do you think that part failure has to do with bad installation?
If it's an ECM motor, it could be. Like if we have a really bad duct system and that ECM motor is having to run really hard to make the CFM that we're asking it to make, then yes, it could be install problems. But I had parts fail that were like an inducer on a furnace. It comes on during the heat cycle, has nothing to do with ductwork, has very little to do with installation. It just failed. It was a crappy part. And
so we're just talking about parts in general here, because a furnace is not part of the heat pump, inverter heat pump system, so to speak. So
right. So I would say ECM motors, whenever I see an ECM motor fail, especially under warranty, I'm always looking at static pressure when we put it back on. And that could be tied to installation or design. Other parts may not have anything to do with that, and they just fail. So I'm not saying this to look, I have an inverter unit in my house. Like, I'm not trying to say that they're the devil, but they've just gotten a bad reputation with some contractors over the years. Some of it's self-induced or self-inflicted. But yeah, I think things are starting to get better. So, but then as we go into now how some of the units work, an inverter essentially means that we can modulate the speed of, usually when we're talking about an inverter unit, we're talking about the compressor being on an inverter. And along with that, the outdoor fan is also going to be on an inverter because it has to match the work that the compressor is doing. So you're not going to get a single speed outdoor fan. It's going to have its own speed control, or at least be multi-speed. And then your indoor blower is definitely going to be either multi-speed or it's going to have some kind of inverter modulating feature to it, because everything kind of needs to modulate together. The thing is that different manufacturers make those inverters think in different ways. They react to the sensors and the inputs that the unit is taking in, and that inverter reacts in different ways. Some compressors speed up when your thermostat is way off from the actual temperature inside. So your thermostat set at 72, it's 76 in the house. The compressor says, oh, we must need more cooling. I'm going to speed up. Other units could care less what the temperature difference is between your thermostat setting and the actual temperature in the room. It's going to modulate the compressor speed based on another input, like an indoor coil temperature or a pressure that converts to an indoor coil temperature. And so you kind of have to know what these inverters are, how they're supposed to think, so that you can troubleshoot them. The other hard part about it is that typically the high-end inverter units, not all of them, but many of them are communicating units, which means that they use a a specific communication protocol. They're sending data back and forth, and that data is not something that we can read with a meter and be able to understand what signals that it's being told to do. That data is their own communication protocol that manufacturer has created for just that system, and they don't really share that information. Whereas traditional units were 24-volt controls, so you can tell when a thermostat is calling for cooling because you could put your meter at the unit. You can see a 24-volt signal on a terminal, and you can kind of see what the unit is trying to do, and you can step your way through that whole control circuit and figure out, where am I dropping 24 volts? That's the part that's preventing me from coming on. The communicating units are they're not like that, and they're very, very hard to troubleshoot. And obviously contractors don't like that either.
Yeah. So here's where this leads me then. And the thing about the indoor and outdoor unit having to communicate, that's a big deal that I don't think even contractors, designers, whoever realize how deep that rabbit hole goes, because here's the thing that happened to me. And I feel like I know a lot about these inverters. I've been down this rabbit hole, like from a design standpoint, like it's mostly our basis of design, unless it's a program driven decision or, cheap contractor that wants something cheaper or something like that. But like for the most part, we were living in the inverter world. So we did quite a bit of research on them. I'm not going to get brand specific here, but there are brands out there where their published data for their cooling mins and their heating mins. So let's just back up for a minute just to talk about why I'm saying this. So in the inverter world, most of the time when we're using inverter, we're trying to satisfy the heating load and the cooling load in a similar manner. We want to be able to serve that, what we call inside the modulation of the equipment. So we want to be able to serve the heating and cooling load. We want the cooling to be able to turn down as low as possible so we get good runtime on the cooling side. So say, for instance, we have a 5-ton heat pump or we have a 5-ton heating load and a 3-ton cooling load, but we have a heat pump that modulates from 60,000 BTUs to 13,000 BTUs, let's say, just making that up. There are some out there that do some similar stuff. So if you have that type of modulation with a 3-ton cooling load and a 5-ton heating load, you feel good about being able to serve that entire load inside the modulation. It can turn down low enough on the cooling load side, and it can get up to the heating load side. Well, that's published. They published that one piece of data in a sheet that you can get somewhere on their website, where that's a whole nother different rabbit hole, like where to find this magical product data at. But like there are places, like if you are savvy enough, you can go find it. And in that product data, it's going to tell you the set cooling min and set heating max for that piece of equipment. We use that as a basis of design. Well, what they don't tell you is, even though it does, most of the time they will have, here's the 2 air handlers this work with, this is the exact match for these 2 air handlers, which in the air handler, you have your coil. So really it's matched with that coil and the speed of that air handler, like you were saying. So they're saying with this air handler or this air handler, you can get this cooling max and this cooling min. But the one thing they may not tell you that I recently found out is there may be a very specific control that is also in that scenario that's not listed there that they need to, and it might, and it's beyond even, is it communicating or not, because they have communicating stats in their brand that actually do communicate with their other equipment. But this one particular brand is like, the only way you're ever going to really get that out of it is if you use this one controller that we don't even send out with the equipment, because we want it to be able to turn on the heat strips and defrost as needed, because some of these inverters have what we call smart defrost cycles, and some of them just turn the heat strips on to defrost. And so this particular one couldn't do that one thing because that's not the way that whole entire algorithm was intended to work. And so because of that, even though they're publishing this set of data, they are really, you're never, ever, ever in life going to get that out of it. And that's just one of the little nuances. I mean, stuff has always really been that way, sort of, in HVAC. Like, you got this stuff on the paper out here in the field, you're not going to get it, but you could feel reasonably sure that if you knew what you were doing enough, the static was here, and this was, these parameters on the outdoor unit were set in your design, you could feel good about getting that thing out of it. But this is like a total, like, you're never going to get that ever, no matter what you do, because you don't have this one piece that we tested it with.
Yeah. And that's, we see that a lot. I think really the only way that contractors, if we're really interested in taking a deep dive into performance, is to put these systems in and to monitor them. And I'm not just talking about monitoring the thermostat, and seeing the thermostat data. I want to see the internal temperatures of that system. I want to see entering and leaving air conditions, temperature and humidity. I want to see refrigerant coil temperatures, compressor speeds. And then you start learning a little bit how these systems think. I have a Bosch unit at my house, and I've made my own little sensor kits, and I can at any given moment know what that system is doing, what the sensible heat capacity is, the latent heat capacity. I can even tell how many watts the compressor is pulling. So I can tell whether that compressor is ramping up, ramping down, trying hard, not trying hard. And you start to sort of map, even if you don't do it data and create graphics, but you can sort of mentally map that on a mild day, when my system has been running for 15 minutes, the air coming out of it isn't that dry. And that's what a lot of inverters end up doing, is when they start backing off, they'll publish what the total BTUs capacity is, and we hope that that's accurate. But what's the split between sensible and latent? Because that's really important, especially in humid climates. What is it doing at part load? And they don't publish that. So really the only way to get that is to hook up your own sensors and start mapping it yourself. And then you start learning some lessons, and you get a few units under your belt. And now you have a little bit better, maybe not quantitative, but qualitative idea of the performance of the system that you're selling. And very few contractors have the time and the patience to do it. I'm weird. That's what I do. So
and it's not about out of the box solution either. You created this thing yourself. Yeah. You had to think up what logically what needed to go where and all that. Like you definitely are thinking different than most even a contractor that may want that information. You're taking it a step further by saying, I'm going to figure out how to get it, where most people stop at the wanting phase at a maximum, if they even want it. And then that's where until somebody says, hey, here's this thing that can do all this stuff, start using it. It's been the same way with IAQ too. Like, yeah, we care until we have to do something about it. Then we don't care that much, probably.
Right. Yeah, different brands, different manufacturers, they react to those temperature, humidity, and deviation from set point inputs differently, and you kind of have to know which one you're dealing with. We've had one conversation about when and when not to use a Bosch, and in my climate, a Bosch makes sense as long as you set it up correctly. And we haven't even covered that as far as commissioning and the setup and the thermostat settings. But yeah, all that matters. And if you don't have a good handle on that, then you are throwing stuff in, cutting it on, and you think that it's going to perform the way you sold it. And it's not. And now you've got a very unhappy customer base.
What you just said about climate dependent is also it's just the craziest point, because like even all these. So the thing that Tim and I were talking about was the Bosch cold weather heat pump that just came out, and not to bash on Bosch or anything like that, but like Tim is the Bosch expert as far as I'm concerned, and I'm like, hey, I got this big project. It's like multi-unit, multi-family project in a cold weather climate. Like, I want to use these Bosch units for it. Like, but I'm having a trouble understanding, the way it's going to serve the load on both ends, basically. And Tim goes, listen, man, it's probably not the best thing. He's like, I love my Bosch. This is his exact words. I love my Bosch, but it's probably not the right thing for that climate zone. I would have never known. It says cold climate heat pump on there. Yeah. You know what I mean? So like and that's me. I'm a guy that's designing this stuff day in and day out. So like, unless you know to your point, unless you know the nuances of that brand, like you're not really going to know the right situation for these heat pumps. Like it's a much more tricky landscape than the marketing would have you believe.
Exactly. Yeah. And, Bosch does make a cold climate heat pump. I think it only comes in a 5-ton outdoor unit. And that if you have, a need for 5 tons of heating, then sure, that might work. But if you're talking about smaller houses and you're using their middle of the road or even their 15 SEER model, when you start looking at, okay, if I have to turn this unit down so that I get really good runtime in the summertime and I pull a lot of humidity in the air, then that also means that it's also turned way down for wintertime. And in my climate, I'm in the North Carolina coast, our winter design temperatures are in the mid to high 20s. That's not a problem. But in, climates like what we are doing a lot in Cincinnati, or, go farther north where your winter design temperatures are in the single digits or in the negatives, all of a sudden that heat pump's performance starts dropping off. And what's going to kick in? Maybe the electric strips. Now you're going to have an unhappy customer. Or the flip side is you have to teach your customer how to go in there in the wintertime and flip dip switches inside their unit and turn, and no one's going to do that. Like, that's not realistic. It's not safe. Like, we're not doing that.
Even if you wrote it on the thing for
we're not doing it.
You used to see the old filter change things, and you'd come down to service the equipment, and there's like one hash mark on there where they came down there one time to change the filter, and that's the last time it ever got done. That's the same thing that would happen.
And the thing that ticks me off, and here's why what I believe why we're in this situation, is that our industry is driven by energy efficiency. We're chasing high SEER equipment, and high SEER equipment only cares about sensible heat. If they can bring the temperature down in your room down to that 75-degree design temperature, they don't care what the humidity is. As long as we brought the temperature down, we can either turn the unit off or the inverter can slow down, and we save energy. And the way they do that is by raising the inside coil temperature, and that kills your ability to dehumidify. Removing moisture in the air is removing energy out of the air, and it takes energy to remove energy. So if we're going to build our unit to remove moisture very well, we're building our unit to remove a lot of energy and consume a lot of energy. And now we don't meet those high efficiency standards that you could compare against your competitors. So now you're building an inverter unit that's only a 14 SEER unit, and your competitor is building an inverter unit that's an 18 SEER unit, and now you're not competitive anymore. So they're forced into this box. And if we have all the technologies already in that unit where we could slow the fan down at a different rate than the compressor, and we could turn that unit into a really good dehumidifier, but they can't do that because the energy efficiency guidelines and the requirements that are there don't allow them to do that and be competitive. And that's really, really sad, because an inverter can be an amazing thing. And then we don't have any control over as contractors, as end users, because the signals that we tell it to speed up and slow down, that's all communication protocol. We're locked out of that. So it's a hard thing.
We need BACnet for residential. I've been saying this for years. We need a common communicating protocol. Like, the government mandated BACnet never even existed before the government just got sick of all these different little proprietary communicating systems in commercial buildings. And I think maybe the BACnet decision was somewhat energy efficiency driven too, because they were like trying to figure out the best way to create common communication so that they can control the efficiencies of the unit as much as everything else when they're doing the automations for the buildings and things like that. So at some point in time, they said, here's the thing everybody's going to use. And ever since then, that's what everybody in the commercial world uses for building communication tools, and even on HVAC systems and stuff like that. It's all driven, like the VAVs and all that's driven through some kind of BACnet network. We need something like that for residential when it comes to all these different communication protocols, because you get one wrong thermostat or one, different when a guy in a shop at a counter is like, hey, we don't have this air handler, but we got this other one. It matches up just as good. And next thing you know, you turn an inverter that you think you're getting all this runtime into a 2-stage or single-stage piece of equipment just by taking that advice. So, like, some of this stuff has got to get a little more streamlined for it to make sense in the mainstream, for it to be pushed, and for there not to be a bunch of problems and it to not have unintended consequences, even on the efficiency side. Like, you get one of these things that run outside the way that it's supposed to, and there's a good chance your energy bill is going to reflect it. I mean, I've seen it happen plenty of times with this stuff, like especially like these inverters. Even if the refrigerant is a little bit low, they start really trying hard to make up for that, and when they do, it ends up being a really high energy bill for the end user, and I don't know what the heck's going on. Next thing you know, they're saying, I thought I installed the most efficient thing out there. Like, well, devil's in the details with that stuff.
And that's why commissioning is so important, and being able to verify using apps like MeasureQuick, where when you start it up, you put it in its test mode. And that's a whole nother thing. When you start up an inverter unit, you just don't turn it on and set the thermostat down to 70. You have to put it in test mode or in charging mode, so it ramps up all the way, and you charge it, and then you take it out of test mode, then it does its thing. But if you've got installers that don't know any better, then they are trickling in refrigerant and adjusting the charge based on things they don't even understand. But using a program like MeasureQuick and documenting the delivered capacity of the unit, the sensible and latent heat split of that total capacity, and then also taking a wattage reading and determining what the coefficient performance to running SEER of it is. And you'll see a lot of things when, okay, I got a 3-ton unit and it's putting out close to 3 tons, but I'm consuming a lot of watts to do it. Then that means I've turned my 17 SEER unit into a 14 SEER unit. I got to figure out why. And a lot of times it is a charge problem where the compressor is speeding up to try to compensate for something that isn't right internally. And it's just seeing the inputs that it's seeing. So setting airflow, setting the charge, and in that order is critical when we're doing commissioning.
And I know there's a lot of there's stuff too with the algorithms with these things now that come into play. That are, it's lightweight programming at some of the boards when you're setting these things up, because you got to have the right algorithm for the exact scenario that you're trying to run. I know that my brother works in the Florida market, and they're doing a lot of these inverters down there because for various reasons. And I know they had with one brand, the brand that they use the most. They were having problem after problem after problem, and the rep finally came out and said, "No, you guys aren't set." Like, to your point, you're not commissioning your systems. You're setting them down and walking away, and you cannot do that. Like, you need to go into the board, and there's an exact algorithm that you need to enable for this thing to be able to run. To put it the way that the other rep, put it, is like, this thing only cares about outside satisfying the coil inside. And you got to make sure that it understands how you want that coil satisfied. And so that's really what that board's doing, is the whole entire programming for the way that unit is going to run is done at that point in time. And if you're just walking away from that, then you did nothing. You just installed a unit that's not going to ever work right. And
installers, unfortunately, don't have that training. If they've been given that training, they sort of mentally checked out around 11 o'clock that morning in the training. Even when I design a system, so when we've done a full design together, and I do this for my designs, if someone wants that complete package, that turnkey package, I go in there to the installation manual for the thermostat, and that thermostat has a bunch of settings in there, and to the untrained eye, you don't know what to set things on, and you need someone with the understanding needs to go in there and say, okay, setting number 27, you're going to choose option 2, setting number 28, option 3, and you need to walk them through setting it up so that in this case with your brother's company, they probably were not putting that unit into its dehumidification mode. It was in comfort mode. So it was trying to satisfy the temperature of the home and running a lot more CFM per ton than if they would have put it in dehumidification mode. It prioritizes dehumidification, which is a great setting. I wish other brands would follow suit. That brand in itself is I think one of the best inverter heat pumps for dehumidification that are out there out of the box. And they're really, really good, but you've got to set it up correctly. My Bosch unit's one of the best out there, but you got to set it up correctly. You got to know how it thinks. And people that don't, it goes from working really, really well to working really, really bad.
Yeah, in a bunch of different bad ways. It's multiple. Your comfort you might be uncomfortable and have very high utility bills at the same exact time. And people are asking themselves, why did I let you talk me into this thing that I just did?
And load calculations and manual S, you can't always go by a load calculation, especially on the heating size. Load calculations are usually going to overestimate how much heat your home needs. Manual S, we've even found, because I'm tracking unit performance, I've gone in there and ran a unit at a certain set of conditions that's on the chart, and my expanded cooling performance chart tells me this unit is putting out this many BTUs, this much is sensible, this much is latent. I go and I test that in the real world, and it's completely different. So they're plopping in numbers in there that aren't really accurate. And what I have found, and this is after this podcast, I'm going to a Bosch install, going there for the inspection. And while I'm there, I've already gathered data from the ecobee thermostat and the Haven IEQ, where I realize that I actually can afford to slow down the blower another notch to get longer run times and better dehumidification. But I would not have known that unless I was paying attention to it, having a live look in on the system with some of these Wi-Fi, the ecobee and the Haven. And now as a contractor, I go in there and I make those adjustments. So every job that I install, included in that price, and that's why it's as high as it is after 6 months I come back for a complimentary health check on it. And I've looked at all that data and I've realized, hey, on a really hot day, we're actually not running 100% of the time. We're still cycling. That means I can get this airflow down a little bit more, get longer run cycles. Stage 2 can kind of trickle in and out of this thing, and we can actually dehumidify better. But you're never going to know that day one when you start up the unit. It's 90 degrees in the house because they haven't had air conditioning all day. You fire it up and you do your best to set up airflow and charge, and you walk away. And if you don't ever look at the performance ever again, then you don't really know how it's actually going to perform once the house gets down to conditions.
So even just talking this through, even if you're using Measure Quick, you still probably need a way to come back and say, hey, let me just make sure that the thing that I thought was good on Measure Quick is staying good on the worst day of the year, or after the system has had time to run and settle in, or however you want to think about it. You have to make sure that it's still working the way that you left it.
Yeah, the cool thing about Measure Quick is under a wide variety of conditions, you can benchmark a system. And then in the internals of Measure Quick, when you come back to check that unit, it knows where the unit should be based on that benchmark. So you don't have to duplicate the inside and outdoor conditions. Measure Quick knows where to move the needle and your targets. What I'm talking about is when we do our due diligence from doing a manual J and a manual S and a proper commissioning, sometimes those numbers in themselves are not accurate. And we realize that we can actually tune this unit to perform even better after we observe it over time. And I would love for contractors to do more of that, observe the unit over time remotely. We're not saying send a technician out there. We're saying observe it remotely. Look at run times, look at temperature and humidity, and start realizing if your unit can run a little bit longer. Did the manual J still overinflate that load? So you set a unit up for 2.5 tons. Can you slow that blower down to make it a 2.2 ton unit and now get longer run times and make it perform a little bit better? And man, that's the difference between a house being 60% humidity and a house being 52%. Just that one setting right there.
I know that like Daikin and Carrier, at a minimum, I'm not sure about the other brands, but Daikin and Carrier both have something that is similar to that. I don't think it goes to the levels that you're taking it as far as, and it might, I don't know. I don't know enough about it, but I don't know that it takes it to the levels of intermittent humidity sensing and some of the other IAQ things that you're doing. But it does allow a contractor from afar, if they enable that with their homeowner, to see things that you normally wouldn't have been able to see. And you can it's sort of like a predictive instead of preventative maintenance feature, where they can see, hey, I got this alert, we probably need to send somebody out there. So I think some of the major brands are thinking that way. It's just not maybe as advanced as what you're doing. But I think the hope is at some point in time, this stuff is just built into systems when they're deployed, and the contractors just can read it, right in their shop, like you say, you're doing, without ever even having to go anywhere.
Yeah, that is one advantage to the inverter communicating systems, is that you typically have those data loggers to some extent built into it, the alerts. And maybe it's not all the information that a nerd like me would want, but it is a lot better. A 24-volt thermostat typically is not going to give you a lot of information because it can't pass that data along. The communication, they're passing packets of data, and you could throw a lot more information into that communication data packet exchange. So, yeah, it is getting better, and I do think that we are moving towards more information being available. I hope it trickles down to some of the standard and medium efficiency systems also, because those are the majority of the systems that are getting installed.
That's what's out there. I mean, like, we think everybody's buying these inverters, but that's not the case. Like, most people are still buying the 2-stage whatever performance system or whatever branding people are using, to call their mid-tier stuff. That's where people live at mostly, is in the mid-tier. Like, they're not buying some of them. I mean, it depends on where you're at. Some is a single stage, but for the most part, somebody wants something a little bit better, but they don't want all the bells and whistles. And technology scares people too. Like my mom's like, I don't want that. I want the same thing I had, 20 years ago. And there, she's like, literally, one part, like, I am who I am. I'm in the industry I am. And my mom lives in Charlotte, North Carolina, and I could not talk her into it. She has a package unit shooting under the house, like a lot of those do. Could not talk her into a heat pump. She still wants the combustion heat because she wants to be able to feel that warm, quote unquote, warm heat from it. Like, and she would not, there's nothing I could say that was changing her mind about that. So that's what she got. AC, funny. Straight cool with heat. Even though and it was, Rheem did, at that time, they had just came out with their heat pump package unit. You didn't even used to see like residential heat pump package units before. There's like one or two manufacturers that have them, but they're starting to pop up now quite a bit.
When I was running my traditional contract business, I sold a lot of mid-tier equipment. I wasn't big on the inverter because of some of the stories I told earlier on in the podcast, but and it was a lot of mid-tier and, of course, the standard efficiency stuff for people that were on a budget. But, you can do a lot with a two-stage system. You can do a lot with it. And the main thing is, you want to set it up so it runs all the time on pretty much your design day, but then on that peak dehumidification day. So when we go to the ASHRAE tables, there is your design conditions that we do our manual J for. Then underneath there's your peak dehumidification day. And in my climate, because I'm southern coastal climate, that really matters. So the hottest day of the year is not always the most humid day of the year. In fact, it rarely is. What you'll find is the most humid day of the year is actually like an 82-degree day. And the hottest, day of the year, the 1% is what they call it on Manual J, is maybe 91 in my climate. But we get a lot of 82-degree days that are really, really humid. The first 3 weeks of this month have pretty much been 82 and like 80-degree dew points. And so what you want is your first stage to be set up so that it runs constantly at 82 degrees. And then at 91 degrees, your second stage is running constantly. And then, of course, you're cycling between the two. And just another thing, just for your listeners, like the one feature I like about the Ecobee thermostat, I think other thermostats are starting to offer it, is reverse staging. So traditionally, when you buy a two-stage system, it will cycle into first stage. The thermostat continues to sense warm air, and it's not getting colder, it's getting warmer in the house. Then eventually second stage comes on. And once second stage comes on, it runs second stage all the way back down until that thermostat satisfies. And then you get an off cycle, and then you got to start all over. Well, if you can do reverse staging, what that thermostat is doing is, as it starts cooling the house back down, when it gets back to that first stage temperature, second stage cuts out and first stage stays on. And so you still continue that run cycle. Your coil is still under dew point. You haven't cycled off. You don't have to worry about a 10-minute cycle next time to get the coil under dew point. And so reverse cycling is like the way to go. And for the life of me, I don't know why it took them until, the last few years to actually offer that in the thermostat.
So what other thermostats have that?
Yeah, I think the Bosch thermostat offers a version of it. It's called latching, from what Jim Bergman was telling me. The Ecobee is where it's at, and you have to manually set up those temperatures and know what you're doing. And I made that YouTube video about how I set up mine, and it's been a really popular video. But that's like some of the secret sauce to getting some of these units to perform better in a humid climate. And that's what I talk about a lot, is humid climates, because that's where I'm in. Colder climates, you kind of have to approach things a little bit differently. So knowing your climate is a big deal when it comes to installing these systems.
And just because something says cold weather, this or that, and especially, here's the thing: if you're in a mixed climate, nothing means anything to you at all in a mixed climate. Like cold weather, great. Well, you also have to worry about the warm, humid weather too, which is the same exact conditions you described, just not as long and not as early. I mean, that's it. But most of the Midwest is having those exact humid day, 82 degree humid days, just like you are down there, and like Florida is, and everything else. Like, it's all up and down, the middle of America. It just depends on how long it lasts. And for you guys, it's a little bit longer and a little bit harder. But like, that is where, especially like Cincinnati on up, like, you're playing with fire on both sides of the spectrum. Like, you got to get really cold. We got to service really cold temperatures, and you got to service really humid summers. So it's a I learned a lot of trial by fire and everything else. Like, coming up in the industry in a mixed climate, I learned a bunch of stuff on both ends of the spectrum where you don't see it one way or the other, but it's also very difficult to make nuanced piece of equipment like cold weather heat pumps work the way people think they're going to work too, because you have to service both sides of it.
You almost can't avoid having supplemental dehumidification.
You got to have it. I wrote the art, I said, I recently put a blog out called The Case for Why Your Air Conditioner Can't Keep Up with Moisture, the case for decoupled latent load or something like that. Like there, especially in anything modern construction, you got to have that extra box. Like, I don't care what anybody says, there's going to be a time where your air conditioner is not going to be on and your house is getting wet. I mean, it's that simple. So you got to be able to take care of that.
I put in a LinkedIn post a few weeks ago where in Michigan, it was more humid than Florida.
Yeah.
And,
I saw
you're going to
it.
get those days.
Yeah.
And it may not be 10 months out of the year. It may be for a few weeks out of the year, but it's long enough where you could have moisture problems in a home. So even a northern climate is not immune to humidity. It's just not that constant, unrelenting 11 months out of the year that like Florida has, where you're just above 65-degree dew point. Yeah, but you do have the challenge with mid-Atlantic, Midwestern, and northern climates, because it does get, it gets humid in New York and Boston and all those areas, that you have to deal with both. You have to have a system that does everything. Where I kind of have it easy here. I size my heat pumps for cooling, and I know that I got heating covered. Up there, you have to, if you size it for cooling and you don't have an envelope that is worth a dang, then your heat pump's going to run out of steam pretty quickly into the winter. And then you're either running heat strips or you're running gas. If you're running gas, at least, you're running gas, and it should be a little bit cheaper than running heat strips. But if you're running heat strips, man, that is a very high energy bill.
The gas is a lot cheaper. I mean, it's the cheapest thing. If you're in a natural gas market, which Cincinnati is, you're not compete. If you're installing heat pumps, it's not because they're financially cheaper for somebody. It's 100%. I don't care if you have an inverter or whatever you have. It's not going to be cheaper than gas after 30 degrees. It's just not. That's just how cheap gas is there. Yeah, that's why it's important to do a load calculation when you're installing a heat pump, especially if you're taking out a gas furnace and putting in a heat pump. Like, you're going from 30,000 BTUs to 50 or something like that. That's a ductwork change. Like, you're doing a whole bunch of stuff more than just changing the heat pump. That's why these cold weather heat pumps came out and people were like, oh yeah, just throw them in. Like, no, there's a lot more to it than that. It's like, Dom from National Comfort Institute made the analogy of a Swiss watch. He's like, we just went from Timex to a Swiss watch. Like, these old heat pumps were Timexes. Now we're installing Swiss watches. Like, that's a great way to put it, because that's what you have to look at. My team's telling me we're running out of time here, so I want to do a couple things before we jump off. Number one, you got a lot of stuff going on. Tell everybody where they can find you at, what you're into, like anything you want to plug, go ahead and plug it.
So my company is Comfort Science Solutions. I'm based out of Southport, North Carolina. I offer three main things: HVAC design, and I can offer that nationwide. I offer contractor training, either remotely or nationwide via Zoom. And I also do local home performance and comfort consulting. So a lot of moisture problems here at the coast. I'm taking a building science approach to it. So if anybody needs anything like that falls into those three buckets, that's what I'm here for. I have a YouTube channel. It's Tim De Stasio HVAC. It's mostly geared towards HVAC professionals, but there's a lot that even homeowners can learn from that, because it's explained in a way that even an HVAC apprentice can understand it. And so, HVAC apprentice, homeowner, it's kind of the same knowledge level there. So you could probably get a lot out of it.
Especially
I'm
in today's age
Instagram.
of information.
Yeah. Sometimes homeowners, because they actually do more research, they know better than contractors. That's a whole nother rant that we'll do another day. But I'm on LinkedIn. It's Tim De Stasio. There's a space between the S and the T, and I'm on Facebook and Instagram. So that's how to find me, my email is tim@comfortsciencesolutions.com. My website is comfortsciencesolutions.com. You can reach out to me and ask any questions. And I do offer some just general consulting. So if you have an issue with your system, and you've had a few contractors out there, yeah, I mean, we can do an hour or two of consulting and probably get you more information than what you've gotten from people that have actually gone there on site. I'm developing some sensors that I can mail out to you that you can connect if you're so brave enough to do that to your own system. Temperature sensors, drill a hole in your duct here, drill a hole in your duct there, wire tie the sensor to a refrigerant line, and I can do some remote consulting there. And one other thing that I just recently came out with is an HVAC course from coursecareers.com. It's a beginner's level HVAC fundamentals course for somebody who is trying to land their first HVAC job. It's an affordable HVAC introductory course, and it helps your employer know that you've actually taken the time to take a course and invest in yourself, and he or she is more likely to hire you than somebody that just walks in off the street. So coursecareers.com, the HVAC course, you'll see my ugly mug on the front of it, and I'm the one that got the privilege to develop that.
Did I hear you call that training with Tim on a commercial? Training with Tim for the course stuff. I thought that had a good ring to it. I was like, they should launch his own thing called Training with Tim.
Yeah, HVAC training, not. You remember the old SNL clips where it was they were making fun of Arnold? We are here to pump you up. No, not that kind of training. Pump you up.
Those were the best SNL days ever.
Oh my goodness! Yeah. Really
okay, so parting shots. If the world ended and they told you to write some piece of advice to your industry on the wall, what are you leaving on the wall?
Do Rolls-Royce work and charge Rolls-Royce prices, but do Rolls-Royce work? These contractors out here, they're charging an arm and a leg, and they're sending untrained people out, and they're not using best practices, and they feel entitled to charge what they charge and not actually be a craftsman. It's a crime. And I would just say, as a contractor, do the best work, charge like you're the best, but be the best. Invest back in training and education. Education is how we're going to fix this industry, if it can be fixed. It's how we're going to get it better. If we can get the newer generation educated that this is the right way of doing it, and the old heads are telling you to do it this way, they're dorks and idiots. Don't listen to them. If we can get this new generation right, then the industry will be a little bit better in a few years.
Yeah, and the new generation is accepting the technology too, which is a part of our generation's problem too. Like they have a problem like buying, and these younger kids love it. So I think we're in a good space. All right, man. Thank you very much. Awesome conversation. I'll talk to you soon, man. Thank you.
Cool.
All right, bye. Hey, everybody. Thanks for stopping by. If you'd like to learn more about the podcast or HVAC two-home performance and any of our services, be sure to check us out on our website at hvactwohomeperformance.com. Also, be sure to subscribe to our YouTube channel at HVAC2HP and find us on Spotify and Apple. While you're at it, leave us a review. The HVAC ADHD Vodcast is produced and edited by the team at Palm Tree Pod Co. Anthony Palmer is the executive producer. Bo Patton is our technical director. Nolan Gray is our audio engineer, and Caitlin Krings is the head of digital. The content for this episode is created by me. Hooday, go Bengals!